Welcome everyone. Thank you so much for being here. This is the Introduction to Analyzing and Interpreting Data webinar. To kick it off, I'm really excited to introduce myself and introduce my colleague, Emily. My name is Brendan Finch, he, him. You can tweet at me at birdbrainfinch. I taught middle and high school science for 7 years. I left the classroom 10 years ago to start rocketlit.com. So that's a leveled reading website for middle school science. And over the last, I guess, 5.5 years, we've been building InterOrbit. So that's just focused around assessments for the NGSS. I wrote a lot of the assessments on the site, and I'm currently doing research to figure out better ways that we can support students and teachers and administrators before and after an assessment. So as you're approaching a rigorous assessment, how can we prepare students for that? And as we follow one of those assessments, what are the things that we can do to allow students to have better access to remediation or elaboration if they nailed it or if they need more support after the assessment. I also just want to state, as things get colder, that hot cocoa is way better with milk. I don't know why people use water as a base for hot cocoa. It seems like it should be a crime. And with that, I'm going to go ahead and pass it over to Emily.
You are correct in it being a crime, Brendan. That is, if you can drink milk or some milk substitute, that is the way to live. So my name is Emily Miller. I am a former high school chemistry teacher. I did that for 10 years. I taught various levels of chemistry. I taught in our alternative learning program, regular, honors, so lots of different strategies to reach lots of different types of students. While I was teaching, I considered myself as an NGSS pioneer and advocate in my science department to try to integrate more of those practices into our teaching. I also was a PLC lead for data-driven dialogue. So as we collected data, I drove a lot of those conversations. Now, currently, I partner with districts here at InterOrbit to help them implement InterOrbit into their classrooms and into their schools. And if I had to pick, I would pick savory over sweet, like any day, like appetizer instead of dessert. I mean, this isn't to say I'm anti-sweet, but there is a winner.
Excellent. Thank you, Emily. I couldn't agree more that a handful of French fries beats like a single bite of chocolate. So awesome. Well, speaking of things that are sweet and savory, I guess depending on your preferences, I'm really excited to talk to you about what InterOrbit is. If you know what InterOrbit is already, then that's fantastic. If you don't know yet, I'm going to give a quick introduction before we dive into our session, so you understand where we're coming from when we talk about this. So InterOrbit is pretty simple. It's a website, and on this website, we find phenomena. So we have over 1,000 phenomena on the site, phenomena ranging that are tied to standards from grades 3 through 12. And with those phenomena, we want students to take what they're learning in class and apply it to new things. And this is what we're going to talk about today around the SEP of analyzing and interpreting data. Because those phenomena are really complex and asking students to just make sense of a phenomenon is really complicated, we write these really carefully scaffolded questions. InterOrbit has kind of a different thesis on how questions should be written than we find in the NGSS canon. And that's where we dissociate, either are we asking students about their knowledge, about the cross-cutting concepts, about the SEPs, or all of those things together. So we have very specific questions that we write to scaffold up to sense making. And then we have really, really detailed reports. So what we're looking at here is the SEP of developing using models. And in this SEP, there are things that students need to know at grade levels 3-5, that's in a big green box, and then grade level 6-8, that's in a yellow box. What we can see here is that there are really specific details where students were successful at the elementary level. So they were able to use a model to test cause and effect relationships or interactions concerning the functioning of a natural design system. They nailed all those questions around that. But students struggled a little bit more with the, develop a model to describe unobservable mechanisms. So this is the level of detail that we offer in all of our assessments and after each question. And so we would love to support y'all with that. Last thing that InterOrbit does is we do a lot of professional learning. If you were in New York or California or New Orleans at NSTA, you know that we provide these sessions that really focus around how can we make sense of sense making and what does it mean to use an SEP, to engage in a cross-cutting concept, to leverage your DCI knowledge and everything else. So we do this in person, we do this virtually. We would love to chat with you and work with you. If you're interested in trying out InterOrbit, you can find a time on our calendar here. I'm going to drop a link to our calendar. We'd love to support you in that. Onward, we are here to talk about the introduction to the SEP Analyzing and Interpreting Data. This is part 1 of a 2-part webinar series. The second webinar is next week. This is providing a basis what we're doing right now is we're introducing and exploring the SEP, analyzing interpreting data, to help prepare for classroom implementation of aligned assessments. We're going to be here for about 30 minutes. First, we're going to talk about sense making. The basis for everything we do is what is sense making. Then we're going to talk about those practices and look at two different criteria that combine what sense making is with how we practice that in science. We'll talk about that in a second. And then Emily is going to walk us through just kind of some modeling for how you can take these criteria and apply them to different assessment items and phenomena and say, are we meeting these criteria partway, all the way, or not at all? And then it's your turn. So we have some sample items that we're going to give y'all. And in the chat, we want to hear you process and see you think about and make sense of this sense making. All right. Ready, Emily? Cool. All right, let's talk about sense making to begin. So first, we want to understand some foundational differences between, like what is sense making, and then maybe what were we doing in our classroom prior. So sense making is it's a term that we see tossed around a lot, and we like to try to define this very clearly for you so that you understand what it is. So prior to the NGSS and the framework for K-12 science education, students would learn sort of these disparate pieces of information and these disparate skills. So these different dots are used to sort of like represent knowledge, skills, ways that we look at science. And what we're looking to do with the NGSS and the purpose of these standards is that now we want to take those disparate sort of like data pieces, that direct instruction, like I know the mitochondria is the powerhouse of the cell. And we want to connect those things to a phenomena or a problem. And so what we want students to see, and in all high quality curriculum and assessments, you're going to see students looking at novel phenomena. So they're going to have one phenomena they're going through in their instruction, and they're going to have another phenomena they use in their assessment, and it will involve something in the real world that they look at. And it's going to be one of the ways that you can say, this is how science comes to life in this very specific way. So sense making is the process of taking not just those ideas and connecting them to the phenomena, but then connecting them to each other so that when we look at novel phenomena, additional things that students have never seen before, sense making can be this binding agent, and it can connect those three dimensions: students' skills or the science practices, their knowledge, and the cross-cutting concepts, the ways that they look in this. And so sense making is the binding agent that connects those three dimensions to the vision of student learning and performance. And that's what's embodied by those three-dimensional science standards. All right, fantastic. Now let's talk a little bit about sense making through the practices. The purpose of this webinar and this series that we're going through, we had one on developing using models a few weeks ago, and we'll probably go on to a different SEP after this. We want to talk about what sense making looks like through the practices. So Achieve has a project that was called the Task Annotation Project for Science. Now this is a part of WestEd, which is a research organization. And there were there are a couple criteria that they use to say, are students genuinely engaging in a practice? And you can meet one or both of these. And if you're meeting both of these, then students are engaging in a practice. So two of these criteria are students using mechanics and skills? Are they genuinely engaging with data? And is there a driving purpose that pushes them forward? And if both of those things are true, then students are approaching or engaging in a practice. So what do I mean by mechanics and skills? So these are procedural features and knowledge pieces. This is, can you read a graph? Can you show me a pattern in this data? So what this really represents are necessary components of the SEPs. You must be able to read a graph, and you must be able to interpret that data. You must be able to see patterns. So this can range, are we tabulating things? Can I represent things in a graph? Can I visualize things? Can I analyze statistics or tables? But this doesn't involve figuring something out. And so an important piece of this is that just because they're using a mechanic of analyzing, interpreting data does not mean that they are making sense of something new. And that is why just engaging with a graph is insufficient evidence of students using an SEP for sense making. And what I used to do in my classroom prior, is that I would teach students all these disparate skills and all these disparate pieces of knowledge. They would know how to, read a graph. They would know how to build a graph. But when I asked them to use all of these things together, they would try to juggle and all the pieces would just fall down. It became really, really complex. So the second piece to what students need to do in order to engage with an SEP is to have a driving purpose. This is the why students are using this practice. This is why they're called practices and not skills, because it's why and how they use this practice. So more specifically, what I mean is this is when students are analyzing and interpreting the data in service of sense making, in service of explaining this new thing. Students are grappling with, they're using, analyzing, interpreting data and their knowledge in order to sort of like grapple with how do I analyze this data? How do I apply that? And so a practice is when students are explicitly making connections among those previously learned ideas and their skills, and they're trying to use those things to apply to a new phenomena. They're trying to figure out a new problem. And that's what sense making is. When students are using both of these different pieces together, they're engaging in an authentic way with the practices. And so just to be really, really clear about what this means, we want to see students using mechanics and skills and a driving purpose anytime they're engaging with a practice. So some questions we can ask ourselves about, are students using a mechanic or skill? So we can say, are they interpreting data in various forms? Are they identifying patterns and significant features? Are they accounting for sources of error? So now we're just looking at the data. This is a mechanic or a skill. And then if they have a driving purpose, we're going to be able to answer questions like, we're going to be able to see attributes like this. Are they interpreting data in a novel situation? Are they making predictions from data? Are they making connections between various data? And if they're doing those things, then we're going to see students using a driving purpose. They're using those mechanics and skills to make sense of something, to reach, other conclusions outside of what we've already taught them. And this is what we're going to do during these sample questions is I'm going to pass it off to Emily, and Emily is going to go through and model the process, kind of thinking out loud of what it would look like to take those two broad categories of criteria and start to apply them to some of our work. And all of this is a lens for y'all to use in your own work and say, are we genuinely engaging students in using the mechanics skills of analyzing and interpreting data? And then do we give them a genuine driving purpose? And that way you can look at your lessons, at your assessments, and say, yeah, we are using a practice, or no, we are not. Emily, I'm going to pass it off to you to kick off this sample question section.
Thank you so much, Brendan. So what we're going to be doing is we're going to be looking at some questions that may appear to be using the SEP, analyzing, interpreting data, and see if they're actually servicing sense making like Brendan was talking about. So the first example I've got here is a middle school earth science question. And I've got these data tables. I actually pulled these from our Inner Orbit website. And the question that is being asked of students is, which of the following are not considered planetary objects in the solar system? So when we're looking at a question, and if we want to see if students are actually using the SEP in the service of sense making, we've got those two components that Brendan talked about. We're looking for, are students using mechanics and skills? And we're looking for, do students have one of these driving purposes? And if we can answer yes to both of these things, then we know that we are, in fact, assessing the SEP for sense making. So, are students using one of these mechanics or skills? So I'm trying to figure out if one of these is a planetary object. And I hate to break it to you if you guys don't remember this or don't recall, but Pluto is no longer a planet. We're sorry, Pluto. And as you can see there, it's under the object table instead of the planet table. It's a dwarf planet. So did students have to use a mechanic or skill? Here's the thing. Students might just remember that Pluto is in fact not a planetary object. They don't necessarily have to reference the table in order to answer this. They're also not necessarily interpreting the data. They're not looking at the numbers. They're not looking for patterns. They're not looking for trends. And so are students using a mechanic or skill in this particular question? No. Does that mean this question isn't worthwhile? No, that's not what we're saying. We're not saying that this is necessarily an inherently poor question, but when we're asking ourselves, are we truly assessing students in terms of the SEP, that's where this is not necessarily hitting that point. Do students have one of these driving purposes? Generally speaking, if they're not using a mechanic or skill, they're not necessarily having a purpose. But just to walk through to kind of think through this process here, We're not necessarily looking at a novel situation. We're not posing students with a question or a real life event or something that they want to try to figure out. We're not making any predictions. We're not making any connections with the data we have here. So no, students are not having a driving purpose. So this is an example of a question that is not necessarily servicing the SEP. So let's look at the same performance expectation, middle school Earth and space science with the solar system and see what else we got here. So this is another question that I pulled from our Inner Orbit website. And the phenomena here is talking about ice caps on Mars versus the ice caps on Earth. And our first figure here is looking at carbon dioxide and the amount of carbon dioxide that is within the ice caps on Mars. And our second figure is looking at the amount of carbon dioxide in Earth's atmosphere. So our question is, the ice caps on Mars have been melting over time, much like Earth's ice caps. Using the figures, do you believe there could be a connection between carbon dioxide on Mars and carbon dioxide on Earth and their ice caps? So remember, we got our two questions here. Are students using one of these mechanics and skills? And do students have one of these driving purposes? So as far as the mechanics and skills go, I have two different graphs that I need to look at here. So I need to notice that we have an upward trend as far as like time and the amount of carbon dioxide in Earth's atmosphere. I'm noticing that the amount of carbon dioxide is decreasing in the ice cap as it's melting. So I'm needing to infer this information and interpret it from these ones. And so as far as mechanics and skills, this is a yes. So definitely looking at our data and trying to analyze and interpret it. But do we have a driving purpose? Because we need both to be able to properly assess the SEP. As far as interpreting data in a novel situation, obviously this kind of depends on if you've talked about the ice caps on Mars and on Earth throughout your lesson. But as far as the novelty goes, I would give this probably a yes, unless you use like this very specific example. We're also making connections between various data. So I need to pull the data from the Mars carbon dioxide graph and from the Earth one, and I have to see if there's a correlation between these two things. So do students have a driving purpose? Yes. So this question is in fact servicing the SEP in terms of sense making. And that's what we're shooting for when we want to give students more practice and more support with the SEPs. All right. Clearly we're all experts now, right? I mean, I did such a fabulous job of that. Like there's no way, y'all. We've got this. So here's what we're going to do. I'm going to throw some questions at you. And I want you to see if the question is in fact servicing the SEP in terms of sense making. So again, looking for those two criteria, mechanics and skills and purpose. So some audience participation here. Let's go. So we're going down to elementary school, elementary life science, third grade to be specific. And so with this novel phenomena, we are looking at hereditary traits and how those traits are inherited from parents. So our question here, which of the following is the correct answer for the coloring of the puppies? All right, remember we're in third grade here. So when looking at this question, we have two questions to answer. Are students using one of these mechanics or skills? And do students have one of these driving purposes? Here's how we're going to participate. I would love y'all in the chat to answer these two questions. You can say yes, yes. You can say yes, no. You can say no, no. You can say no, yes. And bonus points if you share why. So, Brendan, if you want to go ahead and pop the questions on there for me really quick. So the two questions you're trying to answer are students using, oh, balloons. Are students using mechanics or skills? And do students have a driving purpose? I'll give you some time to think about it. Okay, this is awesome. So beautiful. Here we go. So are students using one of these mechanics or skills? I'm going to give this a yes. Students do need to interpret this data. They need to see that you've got the male and the female, and then you've got puppies, and they need to be able to count and decipher the coloring of the puppies from there. Third grade, y'all. When times are a little bit more simple. So yes, we are using a mechanic or skill, but do we have a driving purpose? This might not necessarily be a novel situation. I don't know, puppies and dogs, maybe not super novel. We're not making any predictions. We're not connecting data. So no, there is not a driving purpose. Now, are mechanics and skills important? For sure. We need to be able to see that students have the skills. We need to be able to assess them on the skills, but we ultimately want to get them to using the SEPs in terms of sense making. So this might be like a good scaffolding question, but not where we ultimately want to end up. All right. Still in third grade, still in life science, but now we got some apples. So the question here is, looking at figures 1 and 2, which of these statements makes the most sense? So y'all did such an amazing job participating before. Thank you so much. Let's keep it going. Same question as before. So are students using one of these mechanics and skills? And do students have one of these driving purposes? And again, you can have your answer be yes, yes, no, no, yes, no, no, yes. I believe those are all the options. So go ahead. I'll give you some time to process. What do you think? Okay, I'm seeing answers streaming in. Thank you so much. So are students using one of these mechanics or skills? I'm going to give this a yes. We're using even various forms here. The sweet to tart chart, that was more difficult to say than I anticipated, as well as this hereditary chart over here. Students need to be able to analyze the data here, glean information from it, which is great. And do students have a driving purpose? Yes. In this case, they're connecting various forms of data. So they're trying to make their own connection between those two different diagrams there and seeing if they can come up with their own correlation from it. Wonderful. All right, let's grow up. Let's go to middle school. I don't know how much growing up happens between elementary and middle school, but in theory, there's some. So we've got a middle school performance expectation. We're looking at some physical science, specifically chemistry here. And this phenomena I pulled from our inner orbit website. All of these are pulled from our website, I should say. And so in this case, you have a solution of sodium acetate, and then somebody is sticking their hand into that solution of sodium acetate, and crystals are magically appearing on their hand. And by magic, I mean science. So here's our question. What piece of evidence supports the claim that a chemical reaction did not occur in the GIF? This is not chemical. So same questions as before. Are students using mechanic and skill? And do students have a driving purpose? If you want to go ahead and go in the chat, yes, yes, no, 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 yes, yes, no. All right, thank you for your answers. So are students using one of these mechanics or skills? I'm going to go with a yes on this one. I noticed that some of you said no, and I'm wondering if it's because you're looking at the change that's occurring within the gift rather than the table. And so depending on what you've taught your students up until that point, that could potentially be there. With the table, if we're interpreting the data, what we're looking at is we're noticing that sodium acetate's properties are the same as the ending crystals properties. And so since the sodium acetate and the ending crystals have the same properties, we can infer it is the same substance. And so this is not a chemical reaction because we did not make a new substance. It's just sodium acetate recrystallizing from a supersaturated solution, and it's pretty dope. So yes, to mechanics and skills, depending on where you're focusing. I think I see what some of y'all were thinking. Do students have a driving purpose? I'm going to go with a yes. Novel situation. Okay, they have to make sense of an interesting problem that is occurring here. They're having to make connections between various data, making predictions from the data. Students would be seeing the GIF. So in this case, they would see the GIF and then they would also have this table. So I could see some students saying this is chemical because of like a color change, right? They might be saying it's going from like clear to white. So depending on like what evidence of the chemical changes you discussed, this would be at least a thought-provoking phenomena to bring up and talk about. Great, thank you for asking. Okay, let's do another one. Middle school physical science, still the same deal as before. So for this one, our question is, what happens to atoms during a chemical reaction? So same questions as before. Are they using a mechanical skill? And do they have a driving purpose? I'm not going to give you as much time to process for this one because I want to be respectful of your time, but go ahead and take a few seconds to see what you think. All right, this one's a little bit more divisive. I love it. So, in my opinion, because we could probably fight about all these all day if we really wanted to. In my opinion, are students using one of these mechanics or skills? I'm going to go with a no, because this is really just a DCI level question, a content level question. Do you know what happens to atoms during a chemical reaction? Could they reference the information to help them answer this? Absolutely. But as far as middle school content goes, this would be like a core DCI, core content knowledge question. Do students have a driving purpose? No. While baking soda and vinegar may in fact be novel, the question is not having them make sense of the phenomena. It's just there to look cool and flashy. So it's not actually serving a purpose for them to try to make sense of.
Thank you, Emily, for walking us through that. And thank you, everyone, for being here and chatting with us. So, this is the first webinar in a two-part series, again, that's focused around those SEPs. And this one is really looking at analyzing, interpreting data. So, we have another webinar next week that's focused on scaffolding, analyzing, interpreting data. I'm going to drop the link for that in the chat as well. We'd love to have you sign up for that. This is a baseline webinar, and the second one is going to go a little bit further and be a little bit more complicated. We're going to talk about some of the ways that we are thinking about scaffolding the students up to that SEP. We have some new structures that our colleague Kate is going to present, which we're really excited to share with y'all at that time. So if you'd like to sign up for a free pilot, please do that. If you want to sign up for the webinar, I just dropped the link to that in the chat. And also, if you follow us on YouTube, we post all of these webinars on YouTube, and you can just go watch them later on. If you're watching this as a recording, hello, thanks for being here. This was like one of those really fast webinars, and I'm grateful for the time that you took to grow your practice and to learn. We'd love to see you at the next webinar where we're going to go in much greater detail and depth and build upon all of the principles we talked about in this introduction. That's going to be more focused on scaffolding rather than just introducing the SEP. But thank you all so much. We really, really appreciate you taking the time. Have a beautiful rest of your day, and thanks for being here.